My name is Sean Varley. I'm the Senior Director of Solutions at Ampere. Welcome to Microsoft Build. At Ampere, we're passionate about developers using our technology to innovate and expand what cloud native can be. We've built the world's first cloud native processor. What I want to share with you today are the essentials of cloud native processing, its foundations, solutions, and benefits. We're delighted to see Ampere processors running on Microsoft Azure. We invite you to try out Azure virtual machines built on Ampere Ultra processors. Ampere Ultra is the world's first cloud-native processor. We start out with single-threaded cores. A single-threaded core is very different from the legacy x86 ecosystem because you run to completion one thread, one process. In an x86 processor, you've got at least two threads, and they compete for the resources of the processor. And this creates a very unpredictable environment. You contrast that with a single-threaded core, you get the same amount of performance with every core, and that gives you a high degree of predictability. We also use constant operating frequency. Contrast that with the x86 ecosystem that does frequency scaling. Again, contributing to that overall lack of predictability. Constant frequency and single-threaded cores deliver high predictability. Ampere uses the most power-efficient cores in the industry. This allows us to stack a lot of cores into a processor, and that is part of our differentiation. We have the highest core counts in the industry. You contrast that with the x86 industry, where you've got low core counts and high power per core, giving you that high power processor. Ampere processors are low power, high core count, and very predictable. Finally, we pipeline our cores with a large private L2 cache. That L2 cache is there to operate right next to the core. This gives you the highest performance, and you pipeline all the data, all the instruction set into that L2 cache, giving you the most predictable performance profile for each core. In summary, a cloud-native processor starts with single-threaded cores, consistent operating frequencies, and the most power-efficient cores in the industry. You top that all off with large pipeline caches into L2 close to the processors. This is what really delivers a cloud-native processor. Ampere cloud-native processors are built for the sustainable cloud. Ampere Ultra and Ultra Max processors deliver leadership performance for cloud-native workloads. We've published data on a variety of commonly seen and used applications in the cloud today. Web services, you can see Nginx, databasing, MySQL, Cassandra, in-memory caching, Redis, Memcached, transcoding, x264, x265. These are the common transcoders used out there in video processing today. And in AI inference, we publish MLPerf ResNet 50 results. These results show the foundational disruptive nature of our cloud-native processor. We're showing here both raw performance as well as performance per watt, or power efficiency. This metric, power efficiency, is the one that really shows for the sustainable cloud. This is how we give you disruptive value at a very, very low power consumption. These data points show up to 4 times the actual value in raw performance over the x86 legacy ecosystem. 4 times in power efficiency, and up to 2 or 3 times better in raw performance. This is absolutely disruptive. These are the kinds of results that deliver a generational change in cloud-native computing. At Ampere, we approach enabling the ecosystem in a very, very different way. We actually run in regression over 135 applications every day on infrastructures ranging from our cloud partners to our own infrastructure internally. These applications are ranging from the operating system level all the way to the application level. You can go find this information on solutions.amperecomputing.com. We run these things again every day in regression on Ampere, on Equinix, on Oracle, and now on Microsoft Azure. Ampere addresses the challenges of computing for the next decade. We have processors in the Ultra family to address core to the edge use cases. In the core, we have Ultra Max, 128 cores, spec-int rate integer of 360. That's a very high score, one of the highest in the industry. But for that, you'll only expend 190 watts of power under load. That is incredible. At the edge, you can go from 32 to 64 cores, get spec-int rate scores from 100 to 245, and for that, you'll only expend 40 to 120 watts. This is disruptive value, power efficiency at its perfection. Ampere is committed to an annual cadence. 2 years ago, we launched Ampere Ultra. Last year, Ampere Ultra Max. This year, we're launching our next generation processor, 5nm product on our own cores. We know that performance alone is not enough. We have to deliver sustainable products, and this requires a holistic architectural approach. Ampere Ultra is the industry's first and only cloud-native processor. It's predictable, high performance, scalable, secure, and sustainable. The Ampere Ultra CPU is best in class in performance. You can get it today on Microsoft Azure. From a cloud-native workload perspective, we perform well on all sorts of workloads, from web services to databasing, in-memory caching, media transcoding, and AI inference. We approach software ecosystem enabling very differently. We run 135 plus cloud-native applications every day in regression. Check it out at solutions.amperecomputing.com. Thank you.